For this section, using formulas, we're going to stick with some pretty simple ones, but basically, please realize I can give you a very complicated formula if I want. As long as I tell you what everything stands for and I give you enough information, you should be able to substitute it in, kind of like we did earlier this year with those evaluating expressions, right? You just had to substitute in for the letters and then do order of operations, and there was your answer. So you should be able to do that. I picked these two because obviously this is a geometry class, so let's pick some that you're going to see throughout the year. For area of a rectangle is simply just length times width. Some people call it base times height. That's fine. I'm going to choose this particular formula right now, length times width. So obviously the A is area, as it says right here, length and then times width. And perimeter, if you're going to use a formula, basically perimeter is 2 times the length plus 2 times the width. And here's where order of operations is probably going to become more of a problem because you got to make sure you do it in the right order if you're going to follow that formula. I know some of you might not. Okay? But keep in mind, this is kind of trying to get you to use formulas. And as we go throughout the year, the formulas are going to become more complicated. So you might want to actually work on going through these. All right. So here we go, a rectangle. How about that? All right. According to this, according to the other page, area is going to be length times width. Do we really know which one's the length and which one's the width? It doesn't really matter. No, so let's say you want to make this one the length, then this one is the width kind of by default, right? I mean, it's the only one left. Okay? So if you wanted to do this, you would take the length. So if I fill this in properly, length would be 10 centimeters, correct? If I substitute in for length. And width would be 4 centimeters. I hope you are in agreement so far. And I'm guessing I paired those together, didn't I? Yep. So now all we have to do is multiply, so order of operations really isn't that hard. So the answer is 40 centimeters is unfortunately an incorrect answer. Okay, now here comes the pet peeve. Obviously you know where the 40 came from. And of course when I answer why is it centimeters squared, somebody always gives me the answer, because it's area. I hate that answer. That's not why it's centimeters squared. Why truly is it centimeters squared? Yes. Thank you. Because I just took centimeters times centimeters, which is centimeters squared. Because some people just take, oh, it's 10 centimeters and 4 inches. Can you really multiply those? You can, but then the label's centimeters inches. Have you ever heard that one? No, but that's what it would be, right? Because that's what you took time. So is area always going to be squared? Not necessarily. Are you normally going to convert one of those in the example I just gave you? Probably. And then it might be centimeters squared or inches squared. But that's truly why. Not because it's area. All right, perimeter formula. 2 times width plus 2. It would help if I said the same thing as I was writing. 2 times the length plus 2 times the width. So based on the way that I labeled it, it's 2 times 10 centimeters plus 2 times 4 centimeters. Right? That's how you would substitute into this formula. Again, I know these two formulas are pretty simple. Because let's face it, don't most of you just want to sit here and do this? Put 10 centimeters there, 4 centimeters there, and for perimeter, just add them all up. Right? That's probably what you want to do, and that's okay. But remember, you're going to have harder formulas later. So what happens when I multiply this? Because that's what order of operations tells you to do. That's 20. So it's not centimeters squared? How come? Because I didn't take centimeters times centimeters. I took 2 times 10 centimeters. All right? So it's just centimeters. Plus 8 centimeters. Again, it's not squared because I didn't take centimeters times centimeters. I just took the number 2 times 4 centimeters. Okay? So now when you add these, if I had 20 centimeters and then I had 8 centimeters, well, I have 28. Now when you add centimeters, does that become centimeters squared? No, the only time that happens is when you multiply centimeters times centimeters. So this answer is just centimeters. So hopefully now that I've shown you that, you know why volume is cubed. Because you take centimeters times centimeters times centimeters. That's why. Not because it's volume. Okay. Try this one right now on your own. Again, I would suggest using the formulas to get in that habit. I know some of you will fight me on that. I think I can handle it. All right, let's take a look. Area. Well, if I remember correctly, that's length times width. Again, we don't really know which one's which. Doesn't really matter. You just pick one and go. Length, width. Again, it doesn't matter in this case because it's a rectangle. It's going to definitely matter in some of the other formulas we get throughout the year, but this one for right now does not. So length, 8.5 inches times width, 7 inches. So is this going to have a square on its label? Yes, it is, because you actually took the same thing times. Again, if this was inches and centimeters, that's not going to happen. All right, you got to pay attention. Well, how about 8.5 times 7? That really doesn't come out all that well, does it? Well, it's not that bad, but it's not a whole number. What'd you get? Yep, 59.5. And where am I going to fit it? Right here. 59.5 inches squared. Yeah, because it's area. Right. No, because if I put, inches and yards in there, it's inches, yards. You never hear it that way, but that's what it would be. Okay. And perimeter. 2 times the length plus 2 times the width. So if I plug it and substitute it in properly, 2 times 8.5 inches plus 2 times 7 inches. And I bet you I'm one of the first teachers that actually showed you putting the label in when you substitute. Because normally I bet you everybody else just said put the number in there, right? But the reason you put the label in is because then you can't mess up the label on your answer, right? So 2 times 8.5. Well, that's not actually that bad. That works out fairly well. That is 17 inches. Very good. Plus 14 inches. So actually, this answer kind of works out a little bit better. And we get 31, and it is just inches, correct? Now you might wonder, why does he sit there with those formulas so much? Because, man, I love just doing this, just putting it in here, putting it there, adding them up for perimeter and just multiplying them for area. Well, that's great, but if you're a visual learner, yeah, you're going to love it when you get a picture, but what if you don't get one? Obviously, what's one option? Yeah, draw one, right? I mean, just because they didn't give you one doesn't mean you couldn't draw one. Obviously, if this is the formula, we're going to be talking about a rectangle. So, well, it could be a parallelogram, but. So I'm basically going to tell you that these first two, for 3 and 4, I'm going to tell you that those are rectangles. So could you draw one? Yes, you could. But otherwise, if you don't really need to, though, because you can just substitute. L goes right there. That's a 4. 7 goes right there. Equals 28. Well, why does this one seem a little different than some of the other ones? Yeah. Yeah, what is that? I mean, do I know? Not really, do I? So I would be careful on that. I know in the past you've been told just to do units squared, right? It's probably what you've been told to do. But do I know they're the same units? One could be inches and one could be miles for all I know. All right? So be careful. I mean, if you really want to put units squared just to remind yourself, maybe just say that was some unit and some unit. That's okay. But don't kill yourself. Just put like u squared or something, units squared. Or, if you really want to, write inches on both of them and then write inches squared in your answer. Make the problem work for you. All right? Same thing with this next one. There's no units there. Well, here's P. Okay. 2 times whatever L is. That's a 3. 2, 5. Okay. Well, we don't know units, so basically we just do order of operations. So we're talking about 6 plus 10 here, and we got 16. Again, maybe you want to make it work for you, or maybe the directions will say all units are centimeters or something like that. Watch out for that. That might happen. And, if you want to put in centimeters or something like that, that's fine. And, of course, then this answer would just be centimeters, okay? Because it'd be centimeters here and there, right? So any questions so far? So as I told you, I should be able to basically just give you a formula, and as long as I kind of tell you what it's all about, you should be all right. This is actually the formula for simple interest. The I, you might want to write it down, it's up to you. The I here, that's actually an I know it kind of doesn't look like it, is interest. Okay. P is principal, that just means the amount you started with, that's what that means. Okay. R is the rate, which is normally written as a percent. And T is, what do you think? Time. Yeah. And that's normally in years. Okay. Obviously, some of these formulas get much more complex, but that's why this one's called simple interest. Right? So, do you notice anything? Obviously, it's a different formula. Do you notice anything else about this one compared to the other ones so far? Yeah. It's got a percent, definitely. That's a huge difference. Okay. Anything else? Yeah. Yeah, we're going to have to do a little bit more work on this one. All right. Because what I don't know is going to be in a slightly different spot. Okay? Yes. Yeah, basically, and that's what we were doing. We were solving equations on these other ones, but it was the variable was already by itself, basically, right? Where here, the variable is going to kind of be in the middle of all this mess. All right, so let's replace what I can. Can I replace I? I can, right? It's 42. All right, so replace it. Can I replace P? Yeah, I know it. It's 350. Here's the key to any formula, and that's why I wanted to throw this one in there as well. Any formula, whenever you're going to use a percent as a calculation, don't use 6. In this case, it'd be 6%. Don't use the percent. Use its decimal form. All right? So what is 6% decimal form? Well, basically 6%, do you agree the decimal point is right there at that point? And so what you do is move it twice. Well, what goes in here then? I mean, it's, yeah, 0. So 0.06 is what's going to go in the rate. Again, any formula you're given that has a rate like that, that's a percent, change it to its decimal form if you're going to use it in a calculation. Can I replace T with something? Well, not yet, right? That's what we want to figure out. And whenever I write a T, I put that little curl at the bottom just so it doesn't look like a plus sign. Right? So you're right. This one's going to take a little bit more work, and I'll probably move it up and to the right here so people can see it. Order of operations says, well, we can go to that right side. Can we actually multiply 350 times 0.06? Is that something that you can do? Yeah, that's right. That's legal, right? So we got 42 equals, and I think you might be surprised as to how nice that number comes out. You know, I'm not gonna hurt myself doing these problems. Okay. So what does that come out to be? Yeah, 21. That works out pretty nice. 21. Is the T still there then? If I multiply these two numbers, is the T still there? Yeah, I didn't get rid of it. It's still there. And as we were didn't we solve some one-step equations earlier this year? So we got to get T by itself. 21 is attached by multiplication, so get rid of it by dividing by 21. Because 21 divided by 21 is simply 1, which is a really weird form of it, right? And so T is 2, and more than likely, with this formula, it's understood to be years. I know the label wasn't given, but it is understood to be years. So like I said, I told you what everything stood for, and you should be able to use that formula. It's basically substitution, maybe do a little algebra, and there you go. Any questions? All right. Determine the maximum area for the given perimeter of a rectangle. So I'm going to give you the perimeter, and I want to find the biggest rectangle, the rectangle that has the biggest area possible. State the length and width of that particular rectangle that would give me the maximum area. So I got 24 millimeters. Not very much, is it? Considerably smaller than number 7. So, well, let's just make a rectangle here, and what I would say is we'll do a little guess and check work here. Okay, but we got to know what perimeter means. We got to know what area means. And perimeter means that if I, basically if I add up all those sides, I get 24, right? And so what I would say is just pick a number for one of the sides and see what happens. Perhaps maybe you think that, I don't know, 4 is a good side for over here, right? Then what does this one over here have to be? 4. Because maybe you're just guessing you think this is going to be the answer. So of the 24 that's supposed to add up all the way around, how much have I used? I've used 8, right? Okay. So if I've used 8, how much is left over? That's a little bit harder when you have to subtract like that. 16, right? So does that mean I put 16 on top here? Well, no, because remember there's 2 of those, right? So you kind of got to divide by that 2. And so 8 and 8, right? And all of these are, of course, millimeters if I'm going to add them up. So then what I would suggest you do when doing problems like this is let's just write the area of that rectangle right in the middle, and then we'll see if we can do better. All right? Because we're looking for the maximum area. So maybe it's possible that somebody can do better than, well, what did I come up with for my area here? I came up with 32 millimeters squared. Do you think you can make a rectangle that can do better than 32 as an area? So you're looking for something bigger. Yeah. Okay, heard 7 and 5. Let's see if that actually works out. Let me check. 5 here, 7 there. Let's see, does this actually work out to be, we got to check first, is it actually 24? As a total? Yep. Did he do better than my 32? He did, because what did he get? 35. Can anybody do better? Yes. Which leads us to the question, can you use 6 and 6? A square is a special case of a rectangle. So is a square still a rectangle? Yeah, it is. It's just a special case. So can we use 6 and 6? We can, but we still don't know if it's better. Plus, we still don't even know if it adds to 24. Do we get 24? We do. And did we beat 35? We did. Can we do better? Well, here's you got to be logical. The next thing you're going to do is flip the 5 and the 7, right? So aren't you going to be right back to this rectangle if you try and do better than 6 and 6? You know what I mean? Does that make sense? Okay. And obviously flipping the 4 and 8 is not going to do any better. Okay. Because it's got to add to 24. Okay. So basically, which type of rectangle will every single time give you the maximum area? It'd have to be a square, right? It'll give you that biggest area every time. And so here it said then to state the length and width of the rectangle, okay, it would be 6 millimeters by, and that's how you can do it right there, just by the X there, 6 millimeters. And it did say to determine the maximum area, which Drew got to be 36 square millimeters. Okay, so that would be kind of the answer to that one. Okay, yeah, I know. So why don't you try number 7 right now? Based on that, should you be able to do 7 a whole lot quicker than you did 6? You should, but give it a try. Let's see if you can apply what you just learned. I'm thinking that probably should have been enough time. If you can apply what we did on 6, yeah, number 7, obviously that rectangle is going to be way bigger than this one just because this is millimeters versus miles, all right? But it should be pretty quick because we know the maximum area is going to come from a square. And in a square, all the sides got to be the same. And if 36 is adding up all the way around, what's the easiest way to find out what one side would be? Just divide it by 4. You got 4 sides, right? And so you might have thought this was the wrong number when you first did it, but what is it? It's 9 miles, right? By, all the way around, right? And, you could always check, does that actually add up? Yeah, that's good. That's 36 miles. And then, so 9 miles by 9 miles. All right, that's our dimensions there. And our area then is 81 square miles. Any questions on anything we had today? This is kind of more of a critical thinking idea here. Do some guess and check, and then apply what you learn, though. Don't just be, oh, okay, I got that one. Now we're done. You'll be able to apply it. And then back here, here's formulas if you need it. Sometimes they're nice, sometimes not so nice. And some more formulas here. Many ways of doing those. And please, area is normally squared because you took that label times itself. That's why it's squared.